Hey folks, today I'm in Crystal Lake, Illinois at one of the 12 different service centers, Torqeedo certified service centers. And today I'm joined by Sven, who's the head of the service department. And he's gonna tell us a little bit about the technology of any Torqeedo motor. We have an assortment of different low voltage motors here that are being worked on. Give us an overview of these.
Yeah, hi Jeff. Yeah, Torqeedo offers a range of products in the high voltage and low voltage segment. In the high voltage segment, these are rather big, complex systems. We call them deep blue systems. The operating voltage is around 400 volts DC. Currently, we offer up to 100 kilowatt motors input power, which is equivalent to about 135 horsepower engine. On the low voltage side, we offer smaller engines. They go up to 40 or actually 50 volts. So a lot easier to manage. The smallest one is a 1 horsepower engine, which is our Ultralight. It's a kayak motor. You can see here the pylon of it. It's a very small but still very powerful 1 horsepower motor, 400 watt input power. The next size up is our travel series, which you can see here. Comes also with a lithium battery pack attached to it. This is our travel 1003 motor, which is equivalent to a 3 horsepower engine. The next size up is our cruise model. This comes as a 5 and 8 horsepower version. These are 48 volt systems, mostly used for pontoon boats pushing heavy weights. And then the biggest on the low voltage side, which is our Cruise 10. Here you have a remote version. Cruise 10 motor, it's a 10 kilowatt motor, which goes up to 20 horsepower. Yeah, I think then next is we're gonna have a closer look at our Ultralight system, which you have set up on your kayak.
So one of the unique things about a Torqeedo system is how it communicates data, between the 3 components, which are obviously the motor here, the lithium battery, and the throttle. Can you explain that?
Yeah, you mentioned already we have 3 main components. The electrical motor itself in the back, which is connected with a power and data cable combined to the lithium-ion battery right here. Then we have a data connection here, which goes to your throttle control for the operator. That means when the operator pushes the throttle, for example, the lever forward, it will send a data signal to the battery, which includes the main control circuitry of the system that will process the data and send the speed command to the motor. That means if you move the throttle forward, you can change the speed in forward, you can change it in reverse, and change the speed obviously for it. One important feature is also, which is a big concern for most customers, especially when they're traveling on the water, being stuck in the middle of the lake. And with electric motors, you don't have the easy way to just fill up the tank. So we wanted to provide the customer with a lot of information about the range of the system. Here you can see the big screen on the throttle. On the top, you can see the SOC, the state of charge, which shows you the battery capacity left in your battery. On the very bottom, we see the power consumption, which means if I increase the speed, it will show you how much watts, how much power, electrical power it pulls out of your battery. Right here, you see usually the speed. We have a GPS integrated in our battery, so it gives you the speed over ground of your boat. With those 3 numbers, we are able to give you the remaining range because we know how much battery is left in your battery pack, how much power we draw out of the battery. With the speed reading, we get a remaining range, which is usually displayed here.
So I'm going to put it in a kayak angler's terms or a boater's terms. What this does is say that you are 11 miles away from where you need to go, from the marina, from your launch point, and you're mashing it at full speed, and it says you have 8.4 miles of remaining range. You back off of full throttle until that remaining range number grows up to the 11 miles that you need to get back home. So the definition of IP67 rated waterproof means that you could submerge whatever the item is in up to 1 meter of water for up to half an hour. I'm going to go ahead and start the timer here, and we'll go ahead and sync my battery. It's the 915 watt hour battery, and we'll let it sit there for 30 minutes and check on it, hook it back up, and you see that it works. So Sven, you had mentioned the GPS unit in the battery. Do you mind opening one of those up and just showing us the GPS and just talk to us about the different lithium cell technology, the battery management system, and so forth?
Yep, let's walk into the shop area and then we'll show you the open battery.
Okay.
All right, let's remove the last couple screws here. What I do want to mention in the beginning though is that no customer should ever open a lithium-ion battery pack. When you open those battery housings, you're exposing yourselves to the lithium cell block, which means you are exposing yourself also to some risk here. Only trained personnel should open those batteries. For example, our service partners, they're all trained and certified to work on our lithium-ion packs. You not only avoid the warranty, but you also, again, expose yourself to a high risk. If you open up the battery here now, we'll see a couple of components inside the battery. Turn it around. All right. So when it comes to safety of this battery pack, the first thing which comes into mind is not only what's inside the battery, but also what you can connect to this battery. That means what you can do is you can connect a charger to it to charge the battery, and Torqeedo provides you with a charger specifically designed for this battery, following high quality standards in manufacturing. Secondly, what you attach in terms of motor to the battery is also important. The battery senses what kind of motor is attached to it. It only allows to be a Torqeedo motor, and it also checks that it's functioning properly. Otherwise, it will not give you any power. Now, the safety of the battery itself is obviously very important. We can first see the housing of the battery. You can see a big rubber gasket here. That will ensure that the battery is waterproof, that no water goes in here. Waterproof, Jeff, you explained it before. It's called IP67, where you are able to submerge the battery for 30 minutes up to 1 meter deep. Besides the gasket, of course, we need also to have waterproof connections here. All three connections are waterproof. Doesn't matter if you have something connected to it or not. Then, looking closer to the battery pack, we can see here now the core pack, the cell block. You can see those little green cells. On top of this encaged cell block, we see the circuitry. I mentioned before the GPS, which is located right here, which gives you the speed reading of your boat. The main purpose when it comes to safety, though, of the circuitry here embedded in this cage is the so-called battery management system, short BMS. The job of the BMS is to ensure that the cell block is treated in the proper, safe way. That means the BMS measures the cell voltages of each cell and ensures that you can't overcharge or over-discharge the battery cell. Secondly, there's temperature sensors built into the cell block, so the BMS also ensures that the temperature doesn't get too high. If the temperature increases too high, it will reduce power to reduce the temperature increase or even shut it off. Another feature I want to mention is the so-called cell balancing. Since we have a block of cells connected together, and since not every cell is exactly the same, they age a little different, they lose their voltage a little differently, you want to make sure that every cell has the same voltage. That ensures that, one, you don't overcharge some cells because some other cells didn't get to the final top charge voltage, but also ensures that you have 100% of its capacity, meaning that every cell is charged to the full extent. When it comes to safety, next to the BMS, it is also important to mention the cells themselves. We only work with well-established, well-known battery cell manufacturers like Panasonic, Sony, and Samsung, which have high quality standards and are used all over the world. Secondly, each cell comes even with their own safety features. For example, the so-called PTC, it's a positive temperature coefficient. it's in the end a resistor inside the cell. When the temperature rises inside the cell, it increases the resistor and therefore reduce the current flow through the cell, so the temperature cannot increase. Secondly, a so-called CID, it's a current interrupter device. What it does is if the pressure in the cell increases too high, it will disconnect the path for the current through the cell and therefore also cut off the cell. And lastly, each cell has a safety vent that if in a rare case scenario that the cell would increase so much in pressure that it would burst, instead of bursting, it will be able to release that pressure through that safety valve. And last to mention, when I talk about the safety of the cells, there's also differences in chemistries in the cells. You always usually have that struggle in either having a high performance, high power cell, but then you will lose safety. Torqeedo decided to find a good balance of providing still a very powerful cell, but also providing you with a lot of safety.
So Sven's taken apart, he just took the prop off of a travel motor here, and we're gonna actually pull this apart and show the different components of this brushless motor. That's I guess the first thing we should address, that it's a brushless motor. What does that mean, Sven?
Yeah, so the difference is that to create that changing of the current direction, which creates that magnetic field, which interacts with the magnets in here, which will create the turning of the motor, is done not through brushes. It's done through a electrical commutation, which means that electrical devices will take care of the switching. That means you don't have any mechanical contacts, no maintenance, no losses, what you would have usually with brushes. That means also these motors will run for years and years to come with no maintenance needed.
So in functional terms, I just know from having used regular trolling motors before that have brushes, you know, even if you give it a fresh battery after a couple years, you're not going to get the same power with a brushed motor that you will with a brushless once it's, you know, once those contact points are starting to wear out. The brushless motor is going to be just as strong. And I know I have an Ultralight that you actually opened for me a couple years ago that was like 7 or 8 years old, and it was still giving me, you know, full power. So what we got here? Yeah,
looking close at the motor now, we can see the main components of this electric unit. We have in the front the motor bell. What you see first, this is an Outrunner design. That means the motor bell with the magnets is rotating around the stator, which is stationary in the center with the coils. The benefit is that the forces in between the magnetic fields is further apart from the center of rotation. That means you have a longer arm for your force and therefore more torque can create it. Secondly, when I mentioned magnets, these magnets here you can see here on the outside of the motor bell, there are rare earth magnets. Pretty expensive, but the benefit is that these rare earth magnets are about 10 times stronger than standard ferrite magnets. Therefore, you can create a lot more force and more torque in your electric motor. Going further this way, here you can see the gearbox, a 5-to-1 reduction gear. That means in the end, the fast spinning motor will decrease its RPM on the output shaft, but increase the torque. And that's the benefit of electric motors. You are able to create a lot of torque on the prop shaft. And that enables you to use big props with a big diameter and a high pitch, which is the most efficient way to go through water because you have less slippage if you can spin high pitch, big diameter props.
So I know we'll take a look at the different propeller designs here in a little bit, but Sven's absolutely right. Having a very aggressive pitched, high surface area propeller, you need a high torque motor to be able to do that. And that helps you in situations where you're pushing into a really strong headwind or against a very strong current with heavy weight. That low RPM, high torque motor really does that well.
Another feature I want to mention is the fact that we give the operator more information if something goes wrong. As an example, if I start this motor now, you will see the prop will start spinning. If I disconnect the motor now from the battery, which means it loses communication, the battery loses communication to the motor. obviously the motor will stop, and you will see now an error code displayed here on the screen. This E30, you can look it up in your manual. What it means, in the end, it means there's a communication issue between the battery and the motor. With those different error codes, and we have a bunch of them, which you find in your manual, you can find them also on our YouTube channel. We have service videos available there. You can already narrow down what the problem is. It will help a lot if you contact now Torqeedo or a Torqeedo service partner, what error codes you can see on the screen, and we'll make maybe a decision what you have to send in for repair. Or one more feature to mention is also we have an audible alarm. If your battery voltage or the percentage, the SOC, goes below 30%, it will give you also an audible alarm. It will beep and indicate that you're running out of juice and you better turn around.
All right, let's go ahead and take this one out. Now, I don't recommend submerging it just on a regular basis. We're just kind of proving a point. But what I will say is that this should put your mind at ease in terms of your ability to take this out into rough conditions and know that you're going to get either freshwater or saltwater spray all over it. You're good to go. So part of what makes it IP67 are these connections, and I like to put a little WD-40 on there from time to time. Helps it get a good seal. What's important is that you push these in, make sure that they seat, and it should be easy to turn that knob. That's the main power to the motor back there, and then this is the throttle connection. Put that data cable on there. We'll turn this on. We got power, and we're moving. So I've certainly been in the kind of situation where you're out in rough water and you're taking a wave to the chest and there's just water everywhere. IP67 really means something. You don't have to worry about building a battery box and making sure it's protected from this. It comes that way. So Sven has grabbed an assortment of different propellers here from Ultralight Travel. That's a weedless one for the cruise, and then this is a cruise 10.0, I believe. Yep. Tell us about our propeller design.
What is obvious is that we have all different types of propellers, because each propeller is designed for its specific use, so for this specific motor. We can see that already at the Ultralight, this 1 horsepower motor, we have a pretty big prop in diameter and big pitch. And then every propeller is now changing depending on the characteristics of that motor they're being attached to. These props are designed by a submarine engineer who is specialized into designing props. The prop design plays a major role in the efficiency of the motor, how your system performs, because that's where most of the losses actually happens when you turn the rotational speed into forward motion in water.
So tell us how are we actually measuring thrust? Maybe we can walk over to the tank and get a cruise motor going and talk about how we measure thrust.
Yep,
I mean, I know just when you talk about pound thrust or horsepower or 400 watt motor or 1100 watt motor, all the terms can be very confusing, and I don't know, how do we measure thrust?
Yep. Yeah, Jeff, you already mentioned that there's different ways to measure the performance of a motor. Depending on what industry you're looking at, for example, the gasoline industry, they look usually at shaft power and they give it in horsepower. That means how much power do we get on the propeller shaft. However, that doesn't mean anything in terms of how well this motor performs in a boat. If you have a very bad propeller attached to it, it will not push your boat very well. In the electric industry, most of the time we look at the input power. How much electrical power this motor consumes. For example, a 1,000-watt motor will draw 1,000-watt maximum speed out of your battery pack. Same thing there. This is the input power. It doesn't tell you anything about how well it pushes your boat. It could be a very badly designed, inefficient motor. You draw a lot of power to your battery, it will not reach your boat or to move your boat. That's why we look at the so-called propulsive power. Actually, propulsive power has been used for a long time in other industries. You can see that in cruise ships designs, for example. What we do is we measure the force the motor pushes on your boat at different speeds. That means, think of it as you attach this motor to a test tender, a little boat. We measure the force through a pressure sensor in between the transom bracket and the motor, and measure at different speeds. So we also measure the speed, how fast you're going, and we measure the force the motor puts on your system. If you multiply those two numbers, you will get the propulsive power. So what we do now is we do a test run with our electric motor, for example, at different speeds. We measure the forces we get on the boat. Then we create a table with those numbers. Then we will use the same boat, same condition, weather conditions, and a gasoline outboard, for example, and do the same test again. If we create the table and it's the same values or similar values as the table we're getting with our electric motor, we can say that, for example, this Cruise 4.0 here is equivalent to a 10 horsepower gasoline outboard.
All right, Sven, I appreciate you taking the time to teach us a little bit about Torqeedo technology. You certainly get what you pay for, and with the Torqeedo system, you get a lot of power, you get that range knowledge, you get a lot of safety. You also get all of the access to the different service providers.
Yeah, I want to mention that too. Like if our customer runs into an issue with their product, we built a big service network here in the US and Canada. So if you have any problems, we're trying to supply you with a person who is trained, certified by us, who can help you fixing your problems.
Great. All right. Thanks, man.
Thank you.